Hello everyone. Today we will perform the Izod impact test. So the objective of this test is to find out the impact resistance of mild steel and cast iron material. So to perform this test, the apparatus used is called as an impact testing machine. So you can observe the different components of this machine. So the first important component is this is the pendulum, or it is also called as a striking pendulum because the striker is placed inside this pendulum. The second important component is the anvil. So on this anvil here we have to fix or place our workpiece. Then third is the lever mechanism. So using this lever mechanism we can release the striking pendulum to perform the test. Then this is the scale for which we can measure the impact energy of the material. So this is the construction diagram of the apparatus used for impact test, so called as a impact testing machine. Now step number 1 we have to follow: select the Izod test specimen. So which type of specimen material we have to select? So here you can observe the two types of materials are there. One is a cast iron material and second one is a mild steel material. So we perform the cast iron test in this cast iron material test for Izod test in this video, and for next we will go for the mild steel. So initially we will go with the cast iron material. So we select the cast iron material as a test specimen. So the dimensions of the sample or specimen are: the length is equal to the 75 mm, breadth is equal to the 9.5 mm, then depth is equal to the 9.44 mm, and the depth of the notch. So here you can observe the V notch is there. So the depth of that notch is equal to 4 mm. Next we have to follow the next step. The test for friction loss is conducted by adjusting the pointer to 164 joule. Then the pendulum is released by operating the lever without keeping the specimen. So in this step what we are doing, we are just performing the test without specimen. So pendulum can be released by using this lever, and the loss of energy due to friction is going to measure. So we have to operate the lever without keeping the specimen to measure the loss of energy due to friction. So here the loss of energy due to friction is equal to 2 joule, means without a sample the loss of energy due to friction is equal to the 2 joule. Go for the next step. So this step for trial number 1 we can observe. For trial number 1, the Izod test specimen as per Indian standard is placed in the position. So here you can observe on anvil the sample is placed on anvil, the sample is placed or fixed here. So this is also the diagrammatic representation of the arrangement of the specimen. So here the supports are there which are for the anvil, the parts of components or elements of the anvil. So inside that we have to keep our sample. Then this is the sample which is fixed with the help of the supports. Then this is a striker which is located inside the pendulum and which will strike to this point, striking point for the specimen. So this will be the height of the striker or striking height. So in this step we are just making the arrangement for the specimen onto the anvil. Then in a next step what we are doing, the pendulum is released, the hammer strikes again the specimen, breaks it and swing further, then the observation is noted down. So here you can observe the specimen arrangement on anvil. So here you can also observe the specimen is fixed on anvil. So this type of arrangement is cantilever beam type of arrangement. So it is one end is free and another end is fixed. So this type of arrangement is called as a cantilever beam type of arrangement. Then a striker is placed inside this pendulum. So the pendulum with the striker is here. Then it will be the height of the pendulum is exactly at the 90 degree to this column. So that maximum energy for the in this stage we are releasing the pendulum by using the lever, and we are measuring the value of the impact energy. So as we can observe here, the total loss of energy during the transit of hammer is equal to 6 joule. So the energy for failure of the specimen is equal to the total loss of energy during the transit of hammer minus loss of energy due to friction. So loss of energy due to friction was 2 joule. So 6 minus 2, it will be 4 joule. So the observations of trial number 1 is the initial energy of the hammer is 164 joule. The average loss of energy due to friction is 2 joule. The loss of energy during the transit of hammer is 6 joule. Therefore, the energy for failure of the specimen is equal to 4 joule. So these are the observations for trial number 1. And now we will move for the trial number 2. So we have to follow the same procedure, same as that followed for the trial number 1. So the Izod test specimen as per Indian standard is placed in the position. So this is the anvil. We are placing the cast iron sample into the anvil, fixed it. That is cantilever beam type of arrangement. So this is the position of the sample when it is attached at anvil. So this is a cantilever beam type of arrangement is there. So here you can also observe the sample is attached. Then the pendulum is at 90 degree to with respect to the column. So that is the height of the pendulum, striking pendulum. So the pendulum is released, the hammer strikes again the specimen, break it and swings further, then the observation is noted down. So we can release the pendulum by using this lever. So the sample is a break, and the total loss of energy during transient of hammer is equal to 8 joule. Therefore, the energy for failure of the specimen is loss of energy during the transient of hammer minus loss of energy due to friction. Therefore, 8 minus 2 joule is equal to 6 joule. So this is the observation for trial number 2. The initial energy of the hammer is 164. Means whenever the hammer is at initial position, the energy stored by the hammer is equal to 164 joule. So the loss of energy due to friction is 2 joule. The total loss of energy during the transient of hammer is 8 joule. Therefore, the energy for failure of the specimen is 6 joule. Next, we have to again go for the next trial, trial number 3, or the same Izod test specimen as per Indian standard is placed in the position. Then these are the standard dimensions for the sample. So this is the specimen arrangement. the pendulum is at somewhat height with the energy stored in it 164 joule. Then this is the cantilever beam type of arrangement for the specimen. This is the anvil where we fix the specimen. So what we have to follow in this step, we have to release the pendulum, then striker will strike the sample and we have to note down the whatever is the reading. So release the sample and you will get the total loss of energy is 6 joule. The energy for the failure therefore it will be 4 joule. So this is the trial number 3. The observations are the loss of energy due to friction is 2 joule. The loss of energy due to the transient of hammer is 6 joule. Therefore the energy for failure of the sample is 4 joule. So these are the three observations for three trials. So for trial number 1, the energy for failure of the specimen is 4 joule. For trial number 2, the energy for failure of the specimen is 6 joule. And for trial number 3, the energy for failure of the specimen is 4 joule. So we are taking the average of these three trial reading so that the accurate energy for failure is going to determine. So here 4 plus 6 per 4 divided by 3, you will get the average energy for the failure of the specimen, which is equal to 4.67 joule. So this is the impact energy of the specimen for failure 4.67 joule. So in this way we can determine the impact energy of cast iron material using Izod impact testing machine. Today we will see Izod impact test. So this test is used to check the impact strength or impact energy of material. So the objective of this test is to find out impact resistance of mild steel and cast iron material. So to perform this Izod impact test, the apparatus used is impact testing machine. So you can see here apparatus impact testing machine, which is called as a Izod impact testing machine. Okay. So you can observe the different components of Izod impact testing machine. So first important component is this is a pendulum, which contains the striker, okay, which strikes on the sample, which is placed on here and with. Then you can observe the lever to release this pendulum. Then we can observe the here the scale and pointer, which shows the impact energy of the material. So we will perform here impact test on either mild steel material or cast iron material. So here first step is to select the Izod test specimen. So here two specimens are there in Izod test. One is a cast iron and second one is a mild steel. So we go with the mild steel material as a specimen material first for first trial. So we select the mild steel as a specimen material. So the length of the material or mild steel sample is 76.2. Then breadth is 9.6 mm. Depth is 9.23 mm, and depth of the notch is 5 mm. So here you can observe the V notch is provided with the depth equal to 5 mm. The standard dimensions of these samples are 80 mm by 80 mm is the length, 10 mm is the breadth, and 10 mm is the depth. So that is nothing but the standard dimensions of the specimens are 10 by 10 by 80 mm for this ISO test specimen. So in simulator mode, it will take the standard dimension as a 76.2, 9.6 and 9.23 with the depth of notch equal to 5 mm. Now, the step number two, the test for friction loss is conducted by adjusting the pointer to 164 joule. Then the pendulum is released by operating the lever without keeping the specimen. So here on anvil, we are not keeping the specimen and we are just releasing the pendulum using this lever, and the loss of energy due to friction we are going to determine in this step. So now we are going to release the pendulum using this lever. So here we get the loss of energy due to friction equal to 2 joules. So here without sample we get the loss of energy due to friction for that test equal to 2 joules. Next, step number 3 for trial number 1 is the Izod test specimen as per standard or Indian standard IS 3766 to 1977 is placed in the position. So here you can observe this is the anvil and we are keeping the sample inside the anvil. In this is again the arrangement showing for the sample. So this is the support which are there for the anvil. Then this is our test piece or specimen. Then this is a striking pendulum with a definite angle of peak of the striker. Then this is the direction of the impact. So here it will strike at this point and it will break like this. Then this is the striking height, means for the free end the striker will strike at this point. That height is a striking height. So this is the specimen arrangement. So this type of arrangement for Izod test is a cantilever beam type of arrangement. In case of Charpy test, that there we observe that there is a simply supported type of arrangement is there. So in Izod test, the cantilever beam type of arrangement we can see, as you can observe one end is fixed and another end of the sample is free. Now in next step, the pendulum is released, the hammer strikes against the specimen, break it and swing further, then the observation is noted down. So here you can observe now specimen is placed here on the anvil. So this is again the arrangement of the specimen on the anvil. Then this is the pendulum. Here the striker is located inside the pendulum. Then lever, by using that lever we can release this pendulum. So it will be strike on to the sample. So when we release the pendulum, then we can observe the sample gets break and we got the loss of energy during transit of hammer as equal to 44 joule. So the loss of energy during transit of hammer we get it as a 44 joule. So the energy of failure for the specimen is equal to the total loss of energy during transit of hammer minus loss of energy due to friction. So 44 and a loss of energy due to friction was 2 joule. So the energy for failure of the specimen is equal to 42 joule. So this is a trial number 1 observation. So the observations are the initial energy of the hammer was 164 joule we said. Then the average loss of energy due to friction is 2 joule. Then the total loss of energy during the transient of hammer is 44 joule. So the energy for the failure of the specimen is equal to the impact value is equal to the 42 joule. So Now we will go for the another trial, which is a trial number 2, to get the accurate value of the impact strength of the material. So again, the Izod test specimen as per standard, India standard, each placed in the position at anvil. So the standard dimensions are there for the mild steel material. So it is placed on the anvil. Then the pendulum is released. The hammer strikes against the specimen, breaks it and swing further. Then the observation is noted down. So the sample is placed here onto the anvil. Then striker is attached at the pendulum here inside. Then we can release the pendulum by using this releasing lever, and we will get the result for the loss of energy due to the hammer. So you can observe the specimen it gets break, and the loss of energy during the transient of hammer is equal to 41 joule. So here the energy for failure of the specimen is equal to 39, means so 41 minus 2, that will be 39 joule for the second trial. So the observations for the second trial are the initial loss of or initial energy of the hammer is set as a 164 joule. The average loss of energy due to friction is 2 joule. The total loss of energy during the transient of hammer is 41 joule. The energy loss of failure of the specimen, therefore it is equal to 41 minus 2, 39 joule. Now we will take one more trial number 3 for the same sample with the following the same procedure. So the isotest specimen is as per Indian standard is placed in the position at the anvil. Then we are releasing the pendulum using this lever. Then hammer strikes and we are noted down to whatever the reading of observation. So here in third trial, you can observe the test piece was not broken by striking energy of the testing machine. It means so the impact energy obtained is indefinite. Means here in this third trial, we are not getting the any value for the impact energy or loss of energy or total energy of failure for the this trial number 3, as a sample is not going to break. So here in third trial, loss of energy due to friction is a 2. We are not getting the loss of energy due to the transient of hammer, and we are not getting the energy for the failure of the specimen. So impact value we are not getting for the third trial. So here the observation, after observation, we are finding out the average energy for the failure of specimen 40.50, means the average of all these three trial is taken, that is a 42 plus 39. Okay, so the after that we are getting the average value is equal to 40.50, means we are getting the average of these two only, not this third one, because we are getting the energy of the failure for the specimen for only two trials. So here 42 plus 39 divided by 2 will get the average energy for failure of the specimen. So in this way, we can determine the impact energy or the energy for the failure of the specimen using Izod impact testing machine or testing methods.